Hello class. Today I wanted to make sure you understand how to analyze a question and how to find the important points of a question and then start solving it. We already solved this sample during the lecture, but I want to record this video to make sure we really understand this question. Okay, let's see. This question says we have a tank which up to half of it there's water and above it there's air. The tank is tight and closed. It doesn't have any access to air, to the atmospheric pressure. And the question says find this pressure gauge. Okay, let's investigate. So if I want to find this pressure gauge, I need to find whatever liquids above that point. And the pressure because of those liquids are going to show me the total pressure at that pressure gauge. So what we have here? Here I have water, but not the whole depth of the water, just a piece of water which is above this pressure gauge. So it is going to be this part, which is 2 feet depth. What else? Also, I have air, which is going to have some pressure, and I don't know what is the pressure of that air, but it is going to influence the pressure gauge we have here. So 2 elements, water pressure and air pressure. Imagine I don't have this manometer. So if I hadn't that manometer, I was going to have a tank 100% closed, water here, pressure gauge here, and air there. So if I want to find pressure for this case at the gauge, so I'm going to simply find pressure of this height of water, let's call it H1, and pressure of air here. So pressure at gauge is going to be summation of gamma for water times H1 plus pressure of air at the top. That's it. But for this question, the air pressure is not given. So instead, it says we connected this air to the manometer to read the pressure. So let's get rid of this part, but all the calculations are going to be exactly same. I'm going to follow the same rule. The summation of pressure of the liquid water, that 2 feet of water, plus pressure of the air. But air pressure is going to be find by using this manometer here. Okay, let's investigate manometer. The first point you may see is the unit of air at this top of the manometer. So end of the manometer is closed by this valve, and we have some air pressurized there, 16 psi A. A stands for absolute pressure. And PSI means pound per inch square. So let me write to make sure you understand. Pound per inch square. If you check the other lengths unit, everything is in terms of feet. Let's see. This is feet. This one is feet. Here it is feet. Even here it is feet. So everything is in the length is in terms of feet except this one, which is inch. So you remember you must convert that inch to the feet. Okay. The next point was this A, which stands for absolute pressure. So you need to subtract atmospheric pressure, and we know already that atmospheric pressure is, let me write like this, atmospheric pressure is 14.7 pound per inch square, or 14.69. I think I showed you inside the table. Let's go back and check that table. Yeah, as you can see here, (14.69), which we considered 14.7. Let's go back to our question. Okay, now it's time to read the manometer. First thing we should know, air pressure inside this area is going to be same all over here. Why? Because we consider air pressure constant for the low height differences. For example, if we had a pressure increase in like a few centimeters of water, when we change the depths, for air, we're not going to see that much difference. That is why we're not considering pressure difference because of the column of air here. So everywhere is going to have same air pressure. So if I'm going to have same pressure all over here, so I can start air pressure from there. First, let's read right side of the manometer. So I'm going to read right side. Let me show you. This is the right side of the manometer, the yellow part. Let's read it. It starts with air pressure. Pressure of air, which I don't know, plus what else we have on the right? We have this piece, but that height of liquid is exactly same as this height of liquid. Same liquid, same height, left and right side. So I'm not going to include in my pressure balance between left and right side of the manometer. So this level is going to be my original or jumping level. So instead of adding something, I'm going to just say nothing else. I'm jumping to the left side. Okay, let's see what we have left side. Left side, we have pressure because of 4 feet of this liquid and plus a pressure here, which is air pressure, and it is given. So it is going to be gamma of that liquid, which is given 90 pound per feet cube here, times the height, which is 4 feet, plus the pressure at the top. Let's see what I have there. I have 16 psi A, but it was atmosphere, which I needed to subtract the atmospheric pressure. Now this is going to be gauge pressure, but it is still pound per inch square. I need to convert to the feet. Okay, let me see how I can convert to the feet. I know every 12 inch is 1 feet, and this one is pound per inch square, so I need 2 of these. 12 inch feet. Done. So air pressure is going to be this part. What about water pressure? That one was easy because it's gamma of water times 2 feet, which is given. Also, gamma for water is 62.4 times 4 pound per feet cube. So pressure for our gauge is going to be pressure of air plus pressure of water. And if you calculate this one, you are going to reach 672 probably pound per feet square. Usually we prefer to use PSI, so I need to convert this. Let's convert it. So as you remember, I want to convert this feet to inch, so this time 1 feet is going to be 12 inch, and I need to repeat 2 times to get inch square. So basically I'm dividing by, this is 1/144. So I'm dividing 672 by 144. Therefore, pressure of our gauge is going to be 4.67 psi.